I am Layik Hama. I probably should say graduated from University of Leeds, computer science graduate. So I kind of do more development than pure research, if you like. But yes, I did my PhD at Leeds, and there is at least there was a strong visualization group, and my supervisor, Professor Roy Ruddle, still does quite a lot. And I had the pleasure of attending the IEEE 2019 IEEE Viz conference. So still strong on visualization, and I'm glad that people before me, I didn't have to stick to AI and talk about machine learning. And I must say, I am surrounded by people who still think that for majority of us, we can still do with if-else's rather than get a model, train it on some data, and then. So there's so much that you can do before you really crunch data. I forgot a sticker there, Swisscom, that says, data beats opinion. I'm not quite sure about that because you need opinion to generate the data. So whichever way around that is. But let me tell you a little bit about this project. It's a very, very young project. Started in May. We are trying to name it really eAtlas Geovisualization Engine, but it is funded through them. And yes, you can best describe it as a web-based analysis tool. And we've recently just had a homepage to land on at turing.ac.uk. Yes, and so quick background outline and try to define the atlases. Well, I'll leave most of it to you really, because I think the Cato speaker touched on Vodafone analytics, which was really good for me to follow up on. I don't know how many of you know, but the Jens, my previous speaker from CASA, would know Sir Alan Wilson, who headed Turing Institute, apparently have had a grand vision for quite a long time. And when I was told about an idea of an eAtlas, I was already working on a bit of work for WHO. So we're trying to generate traffic flows in developing countries, in Ghana, in Kathmandu, and also some pollution rates from OpenStreetMap, and really nothing but the population and buildings. But we found ourselves basically needing some sort of a dashboard where we can put data, basically. We were able to generate data. We are able to generate data, but we found ourselves that the mapping libraries on their own and Uber's efforts, I wasn't so much into at the time, probably would have given me a huge kickstart. But yeah, it all started from there. And I do like Turing as an institute and as the man himself. So at least we're going to go on for until April. I'm told there is a bit more budget, but we'll let that. I hope in this presentation I will give you a long-lasting vision, no matter what. So what is an eAtlas? There was a project called DataShine. A visualization geek called Oliver O'Brien at UCL, I think, has done this. Well, no, I think has done this. Another one was one that I saw at the IEEE Viz in Vancouver called Opportunity Atlas. Opportunity Atlas, and there's basically shows opportunities for people throughout their lives. That's quite a huge project. So is DataShine. There is so much data from DataShine as well, which is available on cdrc.ac.uk, I think. And also, I am aware of this project, atlas.cancer.org.au. You can find it. Just type in Google Cancer Atlas Australia, and they're quite similar, really. You've got interaction widgets there. You've got a huge map, and so on and so forth. And this just really tells us, again, what is an eAtlas? For those of you who are aware of Tableau, the doing really well. And I don't know much about Flourish. This is a slide prepared actually by Roger. And what we're trying to do, or what we were trying to do, this is a slide actually from July, that we would be, setting the bar really low. We will say, okay, if this is a decrease in flexibility with preloaded data, pre-configured charts and compositions, and pre-configured interactions, these all would be really almost hard-coded, because they would all be around here, for example. I would say, could we go a little bit more, but keep an eye that that's where tabular is, and obviously our aim is not to repeat what's already done. We'll try and find new ways of doing things, or new basically way of coding. And so the same thing continues here. We started basically with constraining myself to a few file formats, and obviously ways or functions that I can write to process them, and then eventually, obviously, this is where we want to be. There's plenty in here, and I'm told these slides will be published, so I'm not going to go into any of these, but I am using heavily what Uber tech guys, engineers are using, because it's helping me quite a lot, and I don't need to bog down into HTML and stuff like that. So this is Uber Move. They let us have movement data. So, for example, Leeds. And this is their visualization, basically, again, similar to what the other atlases you saw. And so by the time I obviously had an interface up and running, then I was able to download the data, which you will see as something like this. And if you pay attention in here, if you can't see it, I'm not sure if you can, there are basically region names in UK. I'm sure all other countries have got their own geographies, and they're quite complicated. As a data scientist, if you want to visualize this, you really need to be aware of what this is, where you can get the regions, and eventually be able to plot that, whether you're doing it in Python or wherever, in Jupyter or anywhere else, to be fair. So what do? We obviously start with pre-configured everything, but we are at the moment able to, and by the way, everything is open source, so I'll point to those again. You can upload the data, having dealt with this, because that is really, if I could have sorted it by now, I would have be able to recognize this. Yes, this is a UK geography. I know where to get this. You just relax. Yes, I've got it here, don't worry. And pre-process that, get the boundaries, and then obviously the tool which relies on Mapbox and other libraries by Uber will deal with it and give you the visualization. As you can see, is the same isochrone. Obviously, there is also more, because the time is defined here different to what you see there. You need to work that out, and then you will have the same image, basically. Well, given the boundary accuracy. And if I can play this in the next few minutes, I will try to play it.
You need to move the browser over to the screen.
Yep. Thank you.
Go back and now connect. Yeah, exactly.
And on the other side. Thank you. So really, I could have presented this live from my computer, but you can see just literally download that data, for example. And if you know what I've done to that data, which is I've clarified, then in a file that we currently are able to support, you will be able to see it that way, because the application doesn't know really about anything about this data. It will make some guesses, but then that is the mean travel time, which there is a bit of hard code there, but to just showcase what's possible. That's what I wanted to show there briefly. Back to my slides, if I can. Seems I can't. Yep, and yes, so I would have definitely, if I were allowed, I would have spent more time on the actual. I'm not sure if it's active, to be honest. yeah, more time on presenting this, but quickly, a little bit of interaction widgets, basically your map style, for example, certain other things that would apply to certain types of data sets. This is, by the way, 1 million records on here. I'm told we can do 2 million records, obviously, but we will hit bottlenecks, definitely if we are talking nationwide data. But yes, you can drill down furthermore. I think what I have been able to manage in this short space of time is if you give me some data set, I will try to get all the columns and give you access to individual records so you can filter your data and see what happens in your data set. What you see as these bars, again, is an Uber visualization layer called DECGL. And this is what I mean. So if you are looking at road types and you say, can I just see single carriageways, you will be able to, and you'll also be able to quickly get it. So I've left 2 minutes for these challenges. A grand vision is always a challenge, but I love it. To be honest, I had pleasure to deal with another grand vision, and I'm not terrified of it. We just need more power. We need more development. We should be able to get wherever we want to be honest. So grand visions are great, but they are a challenge. And in terms of itself, the engine that we're talking about, I still haven't been able to provide the code that you would be able to connect to your Postgre or your, huge data silos, for example. Data profiling and cleaning is a major area that a lot of work is going on in. And in the Vancouver event, there is so much about AI Viz that I would love to do some, and I've got some ideas in there. And in terms of that middle row that is at the beginning, the transformation of data, we are still at the ETL or ELT, that's extract your data, transform it, and then load it onto somewhere so you can see it. And in that sense, if we focus a little bit on the transform, I still can only deal with 2 types of file formats. Basically, there's so many more that I would love to. Google's, for example, KMZ, shapefile from Esri, and all sorts of others that we have. Obviously, support from Python, from R, that can deal with those, and then your front-end client or even JavaScript is starting to basically catch up with those, and you can do it almost all in your browser without leaving anywhere. DECGL, I just mentioned, is WebGL based, so you're working on the graphics power of your device, so it is as powerful as your graphics unit is. And basically, we need lots of art of visualization. Oliver's work, for example, and others, and DECGL itself is amazing work. And that tells me closer to the end of my talk. But yes, again, one more time to visualize it here. We start with the file format or source of your data. That could be a database, an API somewhere. And then obviously your data frame. We are stuck in data frames for now, but I'd love to get away from this and start thinking some other way other than data frames. Visualization, obviously. And I was told to put that paragraph on there. Thank you very much.